All right, let's talk about something that seems small but has huge consequences in data engineering. We're going to dive into one of the most critical and honestly often overlooked decisions you can make, choosing the right file format.
So, does your file format really matter? I mean, a file is a file, right? As long as the data is in there, who cares what the extension is? Well, it turns out, in the world of data engineering, it matters a lot. And I'm going to show you exactly why.
Okay, so here's the deal. The file format you choose hits you right where it counts, your wallet and your watch. We're talking about real money in cloud storage costs. We're talking about processing speed, how fast your jobs actually run, and of course, query performance, how quickly you can get answers from your data. Get this wrong, and your entire data pipeline could just collapse under pressure. Get it right, and you're set up to scale.
So, to really get why the modern formats are so good, we've got to start at the beginning. Let's talk about the ones we all know and, well, have a love-hate relationship with, the old reliables, CSV and JSON.
First up, the classic CSV. You know this one, it's the plain text, row-based workhorse of the data world. You can pop it open in Excel, a simple text editor, pretty much any tool out there can handle it. It's simple, it's structured, and you can actually read it with your own eyes, which is why it's so great for small, simple data dumps.
And then there's JSON. If the web had a native language, this would be it. Its real superpower is its flexibility, especially with nested data. Think about those complex API responses you get, or those super detailed application logs. JSON handles that stuff beautifully because it doesn't have to fit into a neat little table. It's perfect for that kind of semi-structured information.
But of course, there are always trade-offs, right? With CSV, you get that universal compatibility, but it has no schema. That means there are no rules, which can lead to chaos. JSON, on the other hand, is super flexible, but it's verbose. It uses a lot of text to describe the data, which means bigger files and, you guessed it, slower performance when you're trying to run analytical queries.
And this is where we hit the wall. For all their strengths with smaller stuff, when it comes to big data, they just completely fail. They just were not built for the kind of analytics we need to do today.
So why do they fall apart? Well, when you throw them into a big data system like Spark or Hive, it's a total performance nightmare. The system has to read the entire file every single time, which means tons of unnecessary reading from the disk. It burns up a ton of CPU just trying to figure out what the text means, and they don't compress very well. The end result? Just painfully slow performance.
So if the old tools are broken, what's the fix? Well, it's a totally different way of thinking about how we store data. It's called the columnar solution, and it was built from the ground up for one thing: speed and efficiency for analytics.
And that brings us to the star of the show for many data engineers, Parquet. It's a columnar storage format, which means it organizes data by column instead of by row. This might sound like a small change, but it was designed specifically to handle massive-scale data analytics, and it makes all the difference.
Just look at the power you get with Parquet. Because all the data in a single column is the same type, it compresses like crazy, saving you a ton of storage space. Queries are lightning fast because the system only has to read the specific columns you actually ask for. And it supports this amazing feature called predicate pushdown, which is just a fancy way of saying it can intelligently skip over huge chunks of data it knows you don't need. It's incredibly efficient.
Okay, here's the best way to think about it. Imagine you have a giant phone book. Querying a CSV file is like being asked for one person's zip code, and to find it, you have to read every single line in that entire book. Name, address, phone number, everything. It's so slow. Now, a columnar format like Parquet is like having a separate magical list of just the zip codes. You go straight to that list, grab what you need, and you're done. It is a complete game changer for analytics.
So where do you see Parquet in the wild? Pretty much everywhere in the modern data stack. Building a data lake on AWS S3 or Azure, you're going to use Parquet. Processing terabytes of data with Spark or Hive, definitely Parquet. Building a data warehouse in Snowflake or BigQuery, yep, Parquet. Even storing features for machine learning models. It's become the undisputed industry standard.
Now, Parquet isn't the only columnar format out there. We also have ORC, which stands for Optimized Row Columnar. Think of it as another high-performance option that originally came from the Hadoop ecosystem, and it was really built to make Hive super fast. It's got some cool features of its own, like built-in indexes, and in certain situations, especially with Hive, it can be even faster than Parquet.
Okay, so we've covered formats for these huge static data sets you analyze. But what about data that's not sitting still?
What about data that's constantly in motion, streaming in? For that, we need a totally different kind of tool. It's time to talk about the Avro advantage.
Avro is a bit of a different beast. Now, it's actually a row-based format, like CSV, but with a huge twist. It's binary, not plain text. And its absolute killer feature is how it handles its schema. Avro files are super compact, and they're specifically designed to deal with something called schema evolution, which basically means your data structure can change over time without everything breaking.
So why is this so perfect for streaming? Well, in a system like Apache Kafka, you're firing off tons of tiny messages that need to be packaged up and sent super fast. That's called serialization, and Avro is incredibly good at it. More importantly, we all know systems change, new fields get added, old ones get removed. Avro's support for schema evolution means you can make those changes to your data format without bringing your entire streaming pipeline to a grinding halt. It's a lifesaver.
All right, we've covered a lot of ground, from simple text files like CSV all the way to these highly optimized columnar and binary formats. So now, let's put it all together. Let's create a final decision guide so you can pick the absolute right tool for your specific job.
This table is basically your cheat sheet. You can see right away. CSV and JSON, they're your guys for simple data exchange and APIs, but they get a big no for serious analytics. Parquet and ORC, that's your heavyweight champions for data lakes, business intelligence, and any big query you can throw at them. And Avro, it's the king of streaming pipelines. But just be aware that because it's row-based, it's not the best for heavy-duty analytics.
Let's make it even simpler with some real-world scenarios. You need to export a report for someone who only knows Excel? Just use a CSV. Easy. You're pulling in complex nested logs from a web API? JSON is your best friend there. You need to analyze 10 times terabytes of data in Spark? That is a job for Parquet, period. Streaming live event data from Kafka? You want Avro. And if you're still working in a big Hive data warehouse, ORC is probably your best bet.
So if you walk away with just a few key ideas, let them be these. First, the file format you choose isn't a trivial detail. It directly hits your cost, your speed, and your overall performance. Second, for any modern analytics in the cloud, columnar is king. You just have to be using it. Third, Parquet has really become the de facto standard for data lakes. And finally, when you think streaming and schema evolution, you should immediately think Avro. And that leaves us with one last question, and it's one I want you to really think about. We all know our data is growing like crazy. It's not getting any smaller. So take a hard look at your current data pipelines. Are the file formats you chose last year or even last month really ready for the future? Are they going to handle the scale and the speed you're absolutely going to need tomorrow?